I'm not running that. I'm just sort of spreading the word about that as well. Someone says they're playing audio as they prep their supper. So there we go. Let me know what you're cooking over there. Hopefully it's something tasty, something healthy. We've got Paul, Jeff, I should say here as well. I'm remembering everybody's nicknames. And let's answer before we jump in. Talk about you guys. We're going to answer just this one little question. This is from Guppy Australia, and he says, "I'm new to FPV. I spent thousands on Spectrum gear for my fixed wing over the years." Well, there's I can't really help that part. I was devastated when I realized my NX8 won't work with these little drones. Now here's something that I think Spectrum pilots, it's going to be a tough pill to swallow. When it comes to the world of FPV, and FPV pilots don't always realize this, the products that we have work so well and they are so cheap. For example, and you let me know this, Guppy Australia, what do you think of a price of like $180 radio? Would you say $180 radio is cheap or expensive? Now Spectrum is still sort of, they haven't changed any of their prices terribly. How much is a Spectrum radio? Let's have a look at this together. And if you're in FPV, you might get a bit of a shock. Let's have a look. Oh, even for something like that. Have a look here. Here. We've got a 20 channel transmitter only. I don't know what the differences are. Let's just go to this first one. I imagine the left might be like the cheapest one. Like a color screen. I don't even think that's not terribly high resolution. Let's have a look. Shop now. How much is this going to be? Okay, we're about $400. And that's some plastic gimbals. Nothing about this looks special at all. And I don't know what Spectrum fail-safes are like, or just what their range is like, but we use ELRS in our hobby Guppy. And that's the protocol that most of our radios are on. Something like this radio right here, DX15. This has like incredible CNC gimbals, like full metal gimbal design inside this radio right here. It has a bigger, brighter color touch screen. It looks like it's got more like whistles, dials, switches. How is this one powered? Does it come with batteries or anything? This is, I would guess, nobody should be buying things like this when brands like this TX16S exists. Spectrum sort of just steals your money as far as I'm concerned. When you look at the price and what are you actually paying for when people buy Spectrum, but it is never too late to make the switch. And if you want to jump in and try FPV, you are in for a treat, because this radio right here, and I know, look, it would be great if you could use that radio. And this is one of the few times when I would recommend don't use the gear that you have. If you want to get into FPV, don't use a Spectrum radio. You are much better suited to get something like this when it comes to drones. This is the Radio Master Pocket. I think it's about $65, and a receiver for comparison. Let's have a look here. How much is a receiver for some of these? Let's have a look. Receivers. This might be a good indication. Okay. This one looks like you even need to add some extra things in here. Let's just have a look. A 3-channel receiver. Hopefully that's super cheap. $40, because yeah, that's basically, that to me looks like garbage. Okay, let's have a look at what's a 10-channel receiver. $90. So what are you asking there? Well, I'll answer that. What's your work anyway? I don't know what you mean here. My work is doing this, or do you mean something else? VSynth VRX is finally here, and we are doing some really, really cool things with it. So let me show you on the screen for those of you who don't know. We jump over to here. I'm going to check if we can find Cadex's actual website. This is their VRX. And this is, oh, look at this, it's Happy New Year. It's also, yeah, it's Lunar New Year, Chinese New Year over there. So if you're ordering from China in the next 2 weeks, I don't think anything will be shipping. If it's not out of the country right now, you're probably going to have a bit of a wait. This is the VRX. A lot of people have been excited to fly this because this was our first entry into absolute, like, budget cheap digital FPV. I think, not recently, it was back in December that we first flew ours around. I was really excited, and it has been up in a lot of competition against things like the later released ArcLink with the P1 BTX. But what this was, it's $139 plus a cheap, what is this, 50, oh, no, that's Australian dollars, sorry. It's $99, and we have about a $35 BTX. If I buy this together, what's the price? Does it change? There we go, yeah, a $36 BTX, and here it is. This here. This is the VRX. It is actually smaller than I thought, but still relatively chunky. And I have seen, I'm going to be doing some videos. You're going to see some videos coming out in the next little bit. I want to put this through some more testing, do some more flights with it. I've got some cool things planned. I had reservations, and I've been saying this for a little while, between the P1 system and the Ascent system. The P1 just handled it a lot better. I felt much more confident in terms of breakup and just in terms of a more robust FPV when we're flying around. This is meant to change some things because we're going to have, like, it can do 100 frames per second. It can do a little bit more, and we can plug it into something like this. So this is like something like my Sky Zones, which have a HDMI port in, or I should probably use the Goggles X to do my review, seeing as a CADX product, working with a CADX product. But yeah, this, we'll see how it goes. Now, originally when I reviewed it, it was on an old firmware, and it was like very, very early prototype when I was first looking at the Ascent system. So I'm really excited to see how this goes, but I don't think, from what other people have been saying as well, this isn't the magic bullet that's going to solve all of Ascent's problems. And this is probably where it gets quite interesting as well. Now, the first thing when you look at this, how are you meant to mount this? And that has been a discussion I think I was having last week. If you probably meant to maybe hang this around your neck, because there's no easy way to mount this on terms of a typical FPV goggle. Having a look underneath, we do have one of those little threaded pieces that can go on like a camera tripod or something. But that's not how most of us FPV pilots fly. We like to strap this to the front of the goggle like this. Now, unfortunately, these can get quite big, bulky, and heavy. This is how I use my HD0. I've got my little unit on the front right here. Putting this somewhere, it feels a little bit chunkier as well. And I saw a Matt's tech stream this morning. When he booted his up, it sounded like he was turning on his air conditioner. It was extremely loud, extremely noisy. So, I don't know. It's going to be, it is a great time to have these companies pushing and trying to develop something, and perhaps,
or especially if it seems RPM dependent. Sometimes you'll see little black lines in the feed, and as you throttle up, they get more and more intense. Okay? The motors make a lot of electrical noise because brushless motors are constantly starting and stopping the flow of electricity. The motor has 3 phases, and the ESC sends pulses of electricity, 1, 2, 3, 1, 2, 3, 1, 2, 3, down the different phases, and that's what makes the motor spin. So every time that electricity starts and stops, it creates electrical noise. Okay? Anytime you have current flowing, it creates electromagnetic fields. Anytime there's current flowing, but when there's current starting and stopping, that is especially when there's opportunity to create electromagnetic noise, both in the RF and also in the electrical spectrum. Long story short, ESCs make noise. And if you have an analog video transmitter, that will manifest as visible artifacts in the video feed. When you have digital video transmitters, the electrical noise makes the signal worse, but you don't see it. You just get slightly lower bit rate, for example, and everything. You don't necessarily know why. Okay, so what are you going to do about it? the first thing to do when you have analog noise is check your capacitor. Okay, do you have a capacitor on the build? If not, you need one. And if you have a capacitor, did it like one of the legs break off and it's disconnected? Like, just go back and double check. Maybe you don't have enough capacitance, you use too small of a capacitor. There can be physical things that cause this, like if your motor screws are too long and your motor screws are touching the windings or the wires. Well, a lot of times that will just destroy the motor. It'll literally just burn up. But sometimes it won't destroy the motor, but you'll still get extra noise in the feed. And then sometimes the electrical layout of the quadcopter can cause it. Like if you're powering the video transmitter from VBAT, it'll pick up a bunch of noise. But if you move the video transmitter to a 12 volt or a 9 volt regulator, that gives it cleaner power and it cleans up the noise. This is a topic you can just spend hours and hours, days and weeks sort of trying to ferret out what's causing the noise. But those are the sort of main things to check. I mean, I've probably overlooked, like someone in the chat is like, oh, also you need to check this. Like I always check this. Those are the three that come to the top of my head. What else? What else would you check if you had electrical noise? Like it's not a bad ESC. All ESCs make noise. You need to filter the noise so you don't see it. It's not a bad motor, probably. Like theoretically, an ESC could fail in a way that causes it to make extra noise, but like that's not usually what's causing this. What else could it be? Anything? Anything? No? Okay. Are we picking up plenty? Are we picking up the YouTube chat? I still see. What if I scroll to bottom? Scroll to bottom. Oh, there we go. I had the filter on. Great. Alright. Capacitor is the number one answer. Sticks FPV says, I have a question about analog range and penetration. Range gets multiplied by 1.4 if you double the output power. How is that in terms of penetration? Does it also go by 1.4? Sticks, this is a great question. RF waves, the relationship between power and range is defined by something called the inverse square law. And in fact, I have a video. Maybe I can even find it. Here we go. The weird relationship between range and output power. This is the video you want to get. The weird relationship between range and output power if you want to dive in to like the deep stuff. Right? But the short version is that 2x the power equals 4x the range. I'm sorry, 4x the power equals 2x the range. And 2x the power equals 1.4x the range. These are easy to memorize multiples that help you just do math in your head without having to pull out a calculator and do logarithms or a chart. Okay? And the reason why for that is you can watch this video or you can study the inverse square law, which relates to RF. But what's the effect on penetration? And penetration is a little bit, penetration follows the same sort of basic physical principles, but here's the thing. Let's imagine that we have a radio signal, and instead of being clear line of sight, it's hitting a big concrete wall, okay? The way to think about obstacles is that they have a certain number of dB of absorption. They're going to reduce the signal by a certain number of dB. So if I've got a signal and at 10 feet, that signal is at some power, some number of dBm. Like just for the sake of math, let's say that at 10 feet away, the signal is at minus 40 dBm, minus 40 dBm. Well, double the range, 4x the power, that's 6 dB. So at 20 feet, it would be at minus 46 dBm, okay? So we lose 6 dB going 10 additional feet, or doubling the range. And then we would lose another 6 dB between 20 and 40 feet, and another 6 dB between 40 and 80 feet, and so on and so on. But between 10 and 20 feet, we've got 6 dB, going from minus 40 to minus 46 dBm. Okay. Now let's say that I take a big concrete wall, and I put a big concrete wall right there. Let's say that concrete wall absorbs 20 dB. Now when I go from 10 feet to 20 feet, I'm going to lose 6 dB for the distance, and an additional 20 dB going through the concrete wall. So I'm going to lose 26 dB. So when thinking about penetration, you always think about the range, because the inverse square law, the line of sight loss, is always in play. Okay? But then as you add obstacles between you and the drone, you get additional loss, proportional to, well, it's not just the thickness of the obstacle. Some substances absorb more RF energy, some substances are more transparent, okay? Like plastic is very transparent to RF energy. If we were to hypothetically put a big plastic wall between them, you wouldn't see much change at all, okay? All right. So the way to think about, that's how you think about penetration. What is the effect on range? It depends. It depends on how much absorption the obstacle is having. If I put a 20 dB concrete wall between the 10-foot and the 20-foot mark in that previous example, I'm going to see nothing on the other side of that wall. And I'm going to increase my output power by 6 dB, by 10 dB, by 15 dB, until I increase my output power by enough to get the signal to the other side of the wall. I'm going to see nothing, and then it's going to start creeping through. But basically, if I put a 20 dB wall between me and the transmitter, I'm going to need an additional 20 dB of output power to counteract that. So that what you do, if you're doing math, is you add up the path loss. That's the line of sight loss due to the inverse square law. And then we also add up, we sum the loss of any obstacles between us, and that's how much power you need to get to the other side. So obstacles are very difficult to predict. And in the real world, obstacles are very difficult to predict because also there are bounces and reflections, right? So I might have a concrete wall between me and the drone, but there might be a window in the building, and my signal's going in the window and bouncing around the room, and so I don't actually see 20 dB of loss because I'm not taking the direct line path through the wall. And it gets really complicated to actually predict. But that's sort of, if you simplify it, that's the way to think about it.
On a basic level, though, you are essentially getting 1.4 times more penetration points, right? Like, you know what I mean? Like, because the user isn't going to, like, you know, if I go up by this much point, like if I double my power, am I going to penetrate through 1.4 times as much material? You know, I guess is like a,
yes,
you know what I mean?
yes,
like
yes, but as, the way I think of it, you're right. The math works out that way. But as long as the signal is quote-unquote inside the wall, you don't see the effect of that in the real world because your receiver is never going to be inside the wall. So like at a certain output power, the signal is just like touching the wall. And even that concept is flawed because, of course, when I transmit, my signal goes out eventually everywhere in the universe. Except past a certain distance, it's so far below the noise floor that it can't be distinguished, right? So let's imagine that at a given threshold of power, the signal is just reaching the wall. And now I increase the power by another 3 dB. It goes 1.4 times further into the wall. But until I get it powerful enough to get to the other side of the wall, I don't actually see that effect. So from our perspective, obstacles seem almost like stepwise. That if the wall takes 20 dB of power to get from one side to the other, I don't see any change until I give the full 20 dB and then it comes out the other side. Right? And so it can seem like, well, I added 10 dB of power and I didn't get any additional range. And you're right, you're getting further into the wall, but that doesn't help you. Yeah. Cool. Very cool. I love RF stuff. That used to be my bread and butter back in the day, before I did YouTube and drones. I did RF stuff. Oh, let's see here. What do you think about discus launch gliders? Mark FPD, thank you for being a patron. Mark FPD's in the Discord server, so I know he's a patron. They, him, her. I guess I shouldn't assume that Mark is a he. whatever. Thank you, Mark, for being a patron. What do you think about discus launch gliders? They look awesome. I actually, like, on the list of, hey, that's cool, I should do that sometime, and then I never do. Discus launch gliders are high up there. I used to know a guy, and he, like, bought a discus launch glider and was playing with it, and he was like an FPV drone guy, but one day he did the thing that I will never probably do. And I was tempted to ask, hey, can I try it? But, like, if you screw up discus launch glider, you can crash the shit out of it, and I didn't want to risk, like, destroying his aircraft. For those who don't know, DLG, why can I grab this page? Why can I not grab this page? What is going on? I just wanna grab this page, and I wanna take it out of here. There we go. I don't know why that wasn't working. Let's go to an old.
So, John, what do we got going on today?
This is really exciting here. We have
Back. These are the guys I learned FPV from 6 years ago. It seems like it would have been longer. But basically, a discus launch glider.
This is pretty much my primary edition. When the very first glider I had a good price, I like it used to fly.
It has a finger hook in the wing, and you throw it like a discus.
They're usually selling their use of
And they go
professionals
so
at
high.
competition are buying new planes every year.
Yeah.
So when they're buying 2 or 3 new planes a year, that means I got 2 or 3 used planes to.
And then you glide it back down again. And the guys who are good can, like, just glide it right back to themselves, catch it in their hand, and whip it again. And you think, well, how fun could that be? Like, obviously, lots of things are fun. The guys who are good at this, they'll launch. I'm not going to throw out a number because it'll be wrong. It's ridiculously high. How high they launch and how long they can fly. So that wasn't even like a full launch, and he whipped it.
String on the
There's
bottom.
your little finger hook.
What we do, we are the engine.
Right, that he's not even trying. You just whip it up there in the sky and then wee flying around. Look how much fun you can have. No motor, no nothing. You get 30 seconds to a minute of flying, maybe longer if you're very good. And then if you're really good, you fly right back into your. He's gonna catch it. Come on, buddy. No, yeah, right back into your hand
Let it go.
and whip it again.
Longer flight time, or for aerobatics. Myself, well, you get one guess.
He's not doing the full spin. I guess he doesn't care about that. I don't know. Whee!
With a 1 meter wingspan, it also has benefits over larger versions, like my Blaster 2, which you do look kind of ridiculous running around in circles with. This one,
There we go.
without even moving from a standing still point, you can still get a load of height and a full
Like-
flight.
Like that's wild. I don't know why my YouTube has been doing this lately. Look at this. That looks like a. Was that 1 meter? 2 meter? I don't know. I don't know what's a meter. Wow! Right? Look how high it goes. Anyway, that's a DLG. If you guys aren't familiar with DLGs, just because you're you're just deep in the FPV world, you don't know they exist. They're super cool. You wish they still made them. But surely they still made them, right? Yeah. Anyway, thanks for asking. When do you release your own drone brand? Never. I do not want to be in that business. That seems like a miserable business to be in, and I don't want to be in it. I just get to criticize everybody else's work, and the few products that I have released, I've released a few products. They are incredibly stressful because, I'm never directly the manufacturer, and so anytime I hear about a problem, I have to go back and I have to be like, hey, try to run it down, try and keep the quality high, but ultimately I'm not the one who's like managing the factory. I'm not the one who's responsible for that stuff. Just my name is on it. So obviously I have some influence, but ultimately I have limited influence. And sometimes there are manufacturing problems and it stresses me out just because I want people to get a good product. Sometimes there are customer service issues. People say, oh, I bought this product and then I had a problem and the vendor didn't help me. You know, and obviously sometimes that's BS. Sometimes, you know, obviously there's a lot of, but it's just there's a lot of stress, and you know, that's just with like a few limited products. Never mind a full line. So no, I'm not interested. But you know, thanks for asking. Best beginner analog FPV goggles. You know, I gotta say, I've been hearing. So normally I would say the EV800D, the Eachine EV800D, but this is the HD version. But there is a analog version of these goggles. VR04. No, VR. Come on. There's an analog version. Let me put it on screen. I gotta say, I have the HD version of these goggles for use with the new Beta FPV P1 system. Oh my god. They are not. The fit of the old box goggles leaves a lot to be desired. Okay? Having said that, overall, these seem like a pretty well-made set of goggles. And the fit is not worse than any other box goggle I've ever used. They all fit kind of badly, and you have to kind of work with them. Maybe custom foam, maybe, you know, various things to get them to fit on your face. And they're $75. I would like to try the analog version. In fact, I think Beta FPV is going to send me the analog version, and I'll try it out. Of course, we have to see how the receiver is, but for $75, if it's like barely usable for a beginner, I feel like maybe this is the new budget choice. I don't know. Let's check it out. I was impressed with the screen on the HD version for sure, and the fit was usable. I was able to make it work, although it wasn't perfect, but then for me, that's the big advantage of binocular style goggles, is the way they fit on the face. They fit a lot better. All right. Let's get some super chats knocked out, now that I've babbled for 40 minutes. Exotruck, thank you for a $10 donation. Exotruck just says, thanks for the VTX help. And a $10 donation, appreciate you. I like my Fat Shark Scouts. Fat Shark Scout, also solid. Little better fit, a little smaller, I think. Fat Shark Scout is solid. How much is it, though? I think it's a little more expensive. Fat Shark Scout is $229. Yeah, so I would hope it's better. Yeah, so that people say, what's the best beginner one? They're usually asking for something a little more budget. $229 for the Fat Shark Scout. Yeah. Simply Electronics. Thank you for £5. I started building my first quad with the idea of autonomy, so I went with Pixhawk. I've been trying to make it work for freestyle. Bad idea. Yeah, I knew a guy once upon a time, and he was heavy into the ArduPilot Pixhawk world. That was his bread and butter. And to be like, this guy is literally one of the smartest people I know with ArduPilot. Like, he could make ArduPilot dance. Some of the stuff he did was so impressive. And he gave me an ArduPilot drone that he took as a challenge, that he wanted to make this ArduPilot drone do acro, like, better than Betaflight. And I was like, good luck, but no. And he handed it to me, and he had done everything he could do to make it fly as good as it could. And I was like, yeah, it's not, like, it was okay. Like, obviously, I'm no Min Chan Kim, who's gonna, like, run at, you know, ridiculous speed and, like, notice all the little subtleties of the pit tube. He made it okay. I flew acro on it, and it was okay. It wasn't great. And that was, like, with one of the smartest people I know, working for, like, 2 straight days, doing research on the internet, like, how to make ArduPilot fly good in acro, you know? So I was like, yeah, ArduPilot just not going to be as good in acro. That's not what it's made for. But it could be a fun challenge if that's what you're into. Flugberg. Where can I get useful tips for long-range FPV with a Chimera 7 Pro in the mountains to make sure I don't lose signal? How much of a risk is it compared to a DJI FPV? Thank you for 10 Swiss francs. So here's the first thing. There is not as much information out there about long-range flying. And one of the main reasons for that is that long range flying, most places, isn't legal. It is some form of prohibited. Okay, so there's a lot of people out there who do long range flying and they don't put their shit up on the internet because they don't want to get in trouble. Okay, so you're already at a disadvantage there. The number one piece of information I would say is that as soon as you start stretching your legs, and here's what I'd say. When am I crossing over into long range? When I crash, if I can walk to where the drone is, or maybe drive to where the drone is, and pick it up again, that's not long range, okay? As soon as I cross the line, and if I go down, number one, I might not get it back because I just won't know where it is. And number two, even if I have GPS coordinates for where it is, it's going to be difficult because I'm going to have to drive down this road and then potentially it's going to have crash on somebody's private property or in the middle of the mountains where it's just not accessible. As soon as you cross that line, you're doing long range and you need to absolutely change your mindset. Let me tell you a little story. Definitely not me. This story definitely did not happen to me. Hang on one second. Oh, great. Now that I'm listening, it stopped. I was hearing a noise. It's driving me crazy. Okay. I guess the noise has stopped. Definitely not me. Was test flying a drone that is intended, the desire for this drone, the person who wanted this drone asked if it could fly, not like a super long range, like 5 or 10 kilometers. And it was a very windy day. And whoever this was who told me this story put the drone up, first verified that the battery could last long enough to fly 10. So basically just flew in a square in a field until the battery died. And like in iNav, you can turn on a trip distance in the OSD. And it was like 12 kilometers. You would want 20 kilometers, not unless you didn't intend to fly it home again, which would be silly. So okay, so the drone can fly. The battery will last long enough to fly 10 kilometers. That's the first check, right? And then it's like, okay, well, how's the video system going to be? Is the video going to last 10 kilometers? Let's give it a try. Put the drone up. Climb. You want altitude. Again, 400 feet is the legal maximum. But if you're going to go, what's the rule of thumb? For every 1 kilometer, you climb 100 feet. There's a ratio that long-range pilots know. I don't know it. But you don't get 10 kilometers at 400 feet, especially if there's mountains or hills or other topography. So climb up to whatever altitude and start flying out. Just pick a direction.